Then story height of the building, so that is typical story height of 3 meters. Then you have a maximum dimension along X direction, as you can see on the framing plan. So in the X direction you have 8 plus 8 plus 6. That makes 22 meters, and in the Y direction you have 7 plus 7, so that adds up to 14. Then building height to roof deck, so 3 floors times 3 meter height per floor for a distance or height of 9 meters. Then for dead load at second floor, third floor, and roof deck level, so you have to estimate here or to compute the dead load, no? So ang atong dead load comprise of the weight of the slab, the weight of the beam, and you have to include whatever additional superimposed dead load is being applied, no? So, like for example, cement topping, suspended ceiling, concrete hollow block walls, no? So i-appeal na nimo sa pag-compute nimo sa dead load. Now, at this stage, ang atong na-design ang slab pa o ang intermediate beam o ang stairs. So, naibaw na ta sa mga sizes na ng mga reinforced concrete elements, so we can compute the dead load, no? Their weight. But for the girders and the columns, wala pa man ta maka-design na, no? We don't know yet the sizes of the girders and the columns. So, at this stage, we have to assume, no? So, assume a size for the girder. So, since you have already designed intermediate beams, then of course the girder should not be smaller than your intermediate beams. Kaya ang girder mas bugat man sa load niya i-carry, no? It carries not only the dead plus live but also earthquake loads, no? So just assume a reasonable size for the girders and for the columns. So once you have the assumed sizes for the girders and columns, then you can compute the dead load. So you na lang tabulate. So for the weight of the member, that is just the unit of concrete, this can be taken to be 23.6 kilonewton per cubic meters. Then you multiply that by the volume, no? The volume of the reinforced concrete member. So for the slab, you have the slab panel dimension multiplied by the thickness. For the beam, you have the width times height times the length or the span of the beam, no? So next we have the total dead load of the building. So we just add the dead load at second floor, third floor, and roof deck level. Okay. So in the solution, I have not shown how I computed the dead load, and I hope that you already know how to compute that, no? Weight naman na sa material. Hindi naman tayo na. Unit weight sa material multiplied sa ilang volume. O na siyang weight, no? So next, we have to obtain the seismic factors. And this is where the NSCP will be applied, no? So for the importance factor, I would like to show you in NSCP 2015. So we have something like this, okay? So table 28-3 gives you the seismic zone factor. That is seismic zone factor dahil na sa importance factor. At pang magkitaw ng importance factor na rin, no?